Hello friends, welcome to my channel. In this video, I will be discussing the strength of materials subject MCQ question from Kurbian Gupta book, question number 301 to question number 350. So let's start. Question number 301. A shaft of diameter D is subjected to a twisting moment T and bending moment M. If the maximum bending stress is equal to maximum shear stress developed, then M is equal to. So we know bending stress for the shaft will be 32 m divided by pi d cube. This is equation number 1, and shear stress will be equal to 16t divided by pi d cube. This is equation number 2. So if we equate this equation 1 and 2, we will get m equal to t by 2. So for question number 301, option number A is the right answer. Next question 302. In spring balance, the spring is used for. Option number A is the right answer, to apply forces. Spring balance is a force measuring device, and here the spring is used to apply the forces. Next question 303. In watches, the spring is used to absorb shock and vibration. No, option B is the correct answer. In watches, the spring is used to store strain energy. Next question 304. The springs in car are used to store strain energy. Option B is the right answer. Incorrect, because they are used to absorb shock and vibration from the cars. Next question, cars. Next question, the spring in brakes and clutches are used to. Option A is the right answer, to apply forces. Next question 306. A spring when loaded is permanently distorted and recover its original shape when the load is removed. Option A is the right answer, agree. Next question 307. In a watch, the spring is used to store strain energy. This energy is released. Option B is the right answer, to run the watch. Next question 308. A spring used to absorb shock and vibration is. Option C is the right answer, leaf spring.
Spring is the simple form of spring used for the suspension in the wheeled vehicle.
This is the leaf spring. You can see the diagram. This is the main leaf of the spring, and this is called spring eye. This is rebound clip, and this at the middle is the U clips 2, and center bolt is at here. So this is the leaf spring.
And you know, this spring is connected by the multiple number of plates of different size.
Next question 309. The load required to produce a unit deflection in a spring is called. Option C is the right answer, spring stiffness. Next question 310. In a leaf springs, the maximum bending stress developed in the plate is. Option number B is the right answer, 3WL divided by 2N BT square, and the notations are given here. W is the load acting on the spring, L is the span of the springs, and N is the number of plates, B is the width of the plate, and T is the thickness of the plates. Next question 311. In a leaf spring, the length of all the leaves are equal. No. Option B is the right answer, false. Next question 312. A leaf spring is supported at the. Option B is the right answer, supported at the center and loaded at the ends. Next question 313. In a leaf spring, the deflection at the center is. Option C is the right answer, 3WL cube divided by 8EN cube. We know W is the load acting on the spring, L is the span of the spring, T is the thickness of the plate, B is the width of the plates, N is the number of plates, and E is the Young modulus of the material of the plates. Next question 314. When a closely coiled helical spring is subjected to an axial load, it is said to be under. Option C is the right answer, torsion. Friends, this is helical spring, and the notations are given here. This capital D is the mean diameter, and this small d is the wire diameter, L is the length of the spring, and P is the pitch of the spring. This is helically coiled spring. I am not good at drawing, but this one is to make you understand. Next question 315. When a closely coiled helical spring of mean diameter D is subjected to an axial load W, the deflection of the spring del is given by. Option D is the right answer. 8W d cube n divided by C small d to the power 4. Next question 316. When a closely coiled helical spring of mean diameter D is subjected to an axial load W, the stiffness of the spring is given by. We know stiffness is the load per deflection. So if we divide the load by this deflection of the spring, so we will get stiffness of the spring, and it will be equal to C small d to the power 4 divided by 8 d cube n. Option D is the right answer. Next question 317. Two closely coiled helical springs A and B of the same material, same number of turns and made from same wire are subjected to an axial load W. The mean diameter of the spring A is double the mean diameter of the spring B. The ratio of deflections in the spring B to spring A will be. We know for closely coiled helical spring, deflection is directly proportional to the mean diameter of the coil. So we can write deflection varies as d cube, and d is the mean diameter of the coil. So two springs are given. The mean diameter of the spring A will be double of the spring B. So if we say the mean diameter of the spring B is x, so the diameter of the spring A will be 2x. And if we make the ratio del A divided by del B, which will be equal to dA by dB whole cube, and if we calculate, the value will be del A equal to del B into 8, or del B by del A equal to 1 by 8. So for question number 317, option A is the right answer. Next question 318. In the above question, the ratio of stiffness of the spring B to the spring A will be. We also know the spring stiffness for helical coiled spring is inversely proportional to the mean diameter of the coil. Is proportional to 1 by d cube. And from the question we know the diameter of the spring A will be double of the spring B. So dB equal to x and dA will be 2x. And if we make the ratio Ka by Kb, so Ka by Kb will be equal to dB by dA whole cube. And if we calculate, the value Kb by Ka will be equal to 8. So for question number 318, option number D is the right answer. Next question 319. A closely coiled helical spring is of mean diameter D and spring wire diameter small d. The spring index is the ratio of. Option number C is the right answer. Spring index is the ratio of capital D, which is the mean diameter of the spring, and small d is the spring wire diameter. Next question. Two closely coiled helical springs A and B are equal in all respects, but the number of turns of the spring A is half of that spring B. The ratio of deflection in the spring A to the spring B is. We know deflection is directly proportional to the number of turns of the spring. So we can write del A divided by del B equal to Na by Nb. And the number of turns for the spring B will be double of the spring A. So if Na is x, so Nb will be 2x. And if we calculate del A by del B, which will be equal to Na by Nb, and the final value will be 1 by 2. So for question number 320, option number C is the right answer. Next question 321. The stiffness of a closely coiled helical spring is, option B is the right answer, inversely proportional to the number of turns. Next question 322. Two closely coiled helical springs A and B are equal in all respects, but the diameter of the wire of spring A is double of that spring B. The stiffness of the spring B will be how much as that of the spring A? We know the stiffness of the helical coiled spring is proportional to wire diameter of the spring, and K varies as small d to the power 4. The wire diameter of the spring A is double of the spring B. So if small db equal to x, small dA will be 2x. And if we calculate the value Ka divided by Kb, which will also be equal to small dA divided by small dB to the power 4. And if we calculate the value, kb will be equal to 1 by 16 into ka. So for question number 322, option number A is the right answer. Next question 323. Two closely coiled helical springs A and B are equal in all respects, but the number of turns of spring A is double of that spring B. The stiffness of the spring A will be how much? That of the spring B. We know for the helically spring, the stiffness of the spring is inversely proportional to the number of turns of the spring. We can also write Ka by Kb equal to Nb divided by Na. Na Nb is the number of turns of the spring B and A, and K and Kb is the spring stiffness of A and spring B. And from the question we know the number of turns for the spring A will be double of the spring B. So if Nb is x, Na will be 2x. And if we calculate the value Ka by Kb, which will also be equal to Nb by Na, we will get the value Ka by Kb equal to 1 by 2. So for question number 323, option number D is the right answer. Next question 324. A closely coiled helical spring is cut into two halves. The stiffness of the resulting spring will be, option B is the right answer, double, because we know the stiffness is inversely proportional to the turns or coils of the spring. So if the turns or coils is cut into two halves, the stiffness of the resulting spring will automatically be double. So option B is the right answer. Next question 325. A composite shaft consisting of two stepped portions having spring constant K1 and K2 is held between two rigid supports at the ends. Its equivalent spring constant is. Suppose a composite shaft consists of two stepped portions having spring constant K1 and K2 held between two rigid supports, and it is in stepped portion. So from the figure we can see this is a parallel connection of the spring. So for the parallel connection, the equivalent spring constant will be K1 plus K2. So for question number 325, option number D is the right answer. Next question 326. If the composite shaft in the above question is fixed at one end and the other end is subjected to a torque, then its equivalent spring constant is. Suppose a composite shaft is fixed at one end and other end is subjected to a torque. So from this figure we can see the springs are in series connection. So the equivalent spring constant will be K1 K2 divided by K1 plus K2. For question number 326, option number C is the right answer. Next question 327. A closely coiled helical spring of stiffness K is cut into n equal parts. The stiffness in each part of the spring will be. Option number C is the right answer, Nk. As the stiffness of the spring K is inversely proportional to the number of parts of the spring. Next question 328. The rivets are made from ductile material. Option A is the right answer. Next question 329. For riveting, the size of hole drilled in plate is, option C is the right answer, greater than the shank diameter of the rivet. Next question 330. For a 25 mm hole drilled in plates, the diameter of the rivet shank should be. We know the shank diameter equal to 0.84 into hole diameter. So for a 25 mm hole drilled in plates, the shank diameter will be 0.84 into 25. So in the nearest value will be 23 mm. So for question number 330, option number A is the right answer. Next question 331. According to Unwin's formula, the relation between the diameter of the rivet hole D and thickness of the plate T is given by, option number D is the right answer, D equal to 6 root T. Next question 332. The rivets are used for, option A is the right answer, permanent fastenings. Bolts are temporary fasteners and rivets are permanent fastenings or fasteners. Next question 333. When one plate overlaps the other and the two plates are riveted together with two rows of rivet, the joint is called. Suppose this is two plate and connected with two rows of rivet. This is in plan and this is in section. So this joint is known as double riveted lap joint because these two plates overlap each other and the two rows of rivet are connected. So this is double riveted lap joint. Next question 334. When two main plates are kept in alignment, butting each other and riveted with cover plates on both sides of the main plates with two rows of rivets in each main plate, the joint is known as single riveted double cover butt joint or double riveted double cover butt joint. This is two main plates butting each other and two cover plates are connected by the rivet, and this joint is known as double cover double riveted butt joint. So option number B is the right answer for question number 334. Next question 335. In a riveted joint, when the rivets in the various rows are opposite to each other, the joint is said to be. Suppose this is a connection. These rivets arrangement are such that rows are opposite to each other. Rows of the rivets are opposite to each other. This arrangement or the joint is called chain riveted. Next question 336. In a riveted joint, when the rivets in the adjacent rows are staggered in such a way that every rivet is in the middle of the two rivets of the opposite row, the joint is said to be diamond riveted. Suppose this is two plate connected by the rivet, so the rivets are in staggered way. You can see one rivet is middle of this two rivet, so this joint is called zigzag riveted joint. Next question 337. In a riveted joint, when the number of rivets decreases from the innermost row to the outermost row, the joint is said to be. Suppose this is the connection, where force, this P is the force, and you can see the number of rivets decreases from inside to the outside. This joint is said to be diamond riveted joint. Next question 338. The center to center distance between two consecutive rivet in a row is called, option B is the right answer, pitch. For this connection you can see the center to center distance between two consecutive rivets and this distance along this force to the connection. This distance is called pitch of the rivet. Next question 339. The distance between the center of a rivet hole to the nearest edge of the plate is called, option A is the right answer, margin. Let me show you. Suppose this is the connection. This distance from the center of the rivet hole and the edge of the plate, this distance is called margin. Next question 340. The distance between the center of the rivets in adjacent rows of zigzag riveted joint is called back pitch. Option B is the right answer, false. This is called diagonal pitch. For this connection, this distance, this diagonal distance is called diagonal pitch. This is a zigzag riveted joint. In this joint, this distance between the center to center distance of two rivet holes is called diagonal pitch. Next question 341. The perpendicular distance between the center line of the successive rows is called pitch. Option B is the right answer because it is the parallel distance between the center lines of the consecutive rows in a row. Next question 342. The rivets are generally specified by, option C is the right answer, shank diameter. Suppose this is a rivet, so this upper portion is the head, this portion, this middle portion is the shank of the rivet, and this lower portion is the tail of the rivet. Next question 343. The object of caulking in a riveted joint is to make the joint, option D is the right answer, leak proof. Caulking is the process to seal the air leaks through the cracks or make the joint airtight or leak proof. Next question 344. A riveted joint may fail by, option A tearing of the plate at an edge, right answer. Option B tearing of the plate across the row of the rivets, right answer. Option C shearing of the rivets, right answer. Option D any one of these, option D is the right answer. Next question 345. In order to avoid tearing of the plate at an edge, distance from the center of the rivet hole to the nearest edge of the plate should be, option B is the right answer, of 1.5 D. Suppose for this connection, this distance between the center of the rivet hole and the edge of this plate. This distance should be the 1.5 times the diameter of the rivet hole to avoid the tearing of the plate. Next question 346. A lap joint is always in option A is the right answer single shear. A lap joint is the one where the surfaces of two plates overlap each other. Next question 347. A double strap bar joint with equal strap is option B is the right answer always in double shear. Next question 348. The pull required to tear off the plate per pitch length is option C is the right answer within bracket P minus D into T into sigma T. P is the pitch of the rivet, T is the thickness of the plate and sigma T is the permissible tensile stress of the rivet material. Next question 349. The pull required to shear off a rivet in a double shear per pitch length is pi by 4 into d square into tau in single shear and pi by 2 into d square into tau in double shear. So option number D is the right answer for question number 349. Next question 350. The pull required to crash the rivet per pitch length is option B is the right answer D T sigma C, where D is the diameter of the rivet hole in mm, T is the thickness of the plate and sigma C is the crushing stress for the rivet material. So friends, I will be back in the next video. As I said you earlier, if you have any doubts about this solution, please let me know by commenting. Thank you.